Oh, it didn't repeat. Oh, hold on a sec. GM. What's going on, everybody? Welcome to the stream. Welcome for those of you watching on YouTube or on Twitter. Today we are doing some competitive audit judging of the TSender codebase, and we are here with In All Honesty or Dishonesty, or what do you go by now? What's your tag?
It's In All Honesty.
We're here with In All Honesty. How you doing today?
I'm fine, thanks. How are you?
I'm doing well. Very excited to do some judging here. So, yeah, as most of you know, In All Honesty has been doing a lot of the judging on the CodeHawks platform, and we figured we would do a little bit of streaming to judge the TSender codebase, right? As a lot of you know, this is a hyper gas optimized airdropper smart contract written in several languages. It's written in Solidity, and then it's written in Yule, and then it's written in raw opcodes in straight up Huff. So when we get down to that low level, that assembly level code, more bugs can show up. So I haven't looked at any of these submissions yet from the competitive auditors. I know In All Honesty has looked at some of these, so he's got a little bit of an edge on me for the judging here. But yeah, we're going to be judging this live. We're going to be going through everything. For those of you who are unfamiliar with CodeHawks, definitely be sure to go check out CodeHawks and do some competitive audits. They're a ton of fun. And then maybe I'll roast your submissions live in the future. Any questions before we get started? I can see the comments coming in both from Twitter and from YouTube. Yeah, In All Honesty is the most honest. Cool. Yeah. In all honesty, any questions before we get going? Oh yeah. Oh, thanks. All right. Cool. Let's switch on over to the share screen here. This is kind of the code base. Actually, we want to do 2024 or 2025 or 2024-05 TSender Cypherin. That's like kind of the GitHub repo, the actual project. This is the GitHub repo associated with the audit here. So this is what was in scope for the competitive audit. This was our wonderful little logo we made. Just to kind of briefly go over the code base before we go into the judging. So the idea of this was it would be a super hyper gas optimized code base where it's written in Huff, but with additionally like a lot of checks though. So we want it to be hyper gas optimized, but hyper safe. But we also built, and then myself and the Cypherin team, we built this code base. So obviously I'm like extra familiar with it. I actually built a lot of this live. If we go down to the about section, there's mainly 3 these smart contracts were in scope. This tsender.sol, this was the Yule Solidity implementation. This was basically an adaptation of what the Gaslight team came up with. We added a couple different checks. We tweaked a little bit of the assembly. And then we took that and we rewrote the whole thing in Huff, which is this raw opcodes implementation. And then we said, okay, well, those checks are costing some gas. So let's also build a code base where there's no Rails. It's just raw, like super, super gas optimized. If you mess up, too bad for you, but like super, super gas optimized, no safety rails. And then we have tsender.sol, which is pure Solidity, just a reference implementation, right? And for those of you who are building code bases and want to do some of this gas optimized stuff, having a Solidity reference implementation, I think, is incredibly important, because then you can formally verify against that reference. So if you want to build these hyper gas optimized smart contracts, build them in like a higher level language first, and then formally verify them. And I think that's going to be kind of the future. Each one of these contracts has 1 or 2 functions: airdrop ERC20 and R valid lists. These are the main functionalities to do this airdrop. And then this R valid list is to basically check if your lists are valid. And obviously the T-senders have the check, and then the no check does not have such check. So then there's some features, some comparisons to different gas costs, blah, 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 and then how to actually work with it, blah, 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 blah. Okay. In all honesty, you ready to jump in?
Let's go.
All right. Hell yeah. Let's do it. So like I said, he's kind of seen some of these already. Many of you who have not seen the judging dashboard, this will be the first time you see the judging dashboard as well. It's changed a little bit since I judged last. So if I get things wrong, let me know. But what's kind of cool. Okay. So we have 110 submissions. Oh, so in all honesty, this might be a quick stream here. We're going to rip right through this. All right, cool. All right, cool. We can see kind of community judgment on the right side. So those of you who participated in the community judgment, this is kind of like the indicator to us judges. Hey, is this valid or not? Right. And it's going to help us judge as well. Oh, what up? Matt Durkin, one of the devs behind the CodeHawks platform. Everyone say hi to Matt. But yeah, this is going to help us judge. Sorry, I feel like I've prepped this so much. In all honesty, yeah. Anything to add, or I've just been ranting? I mean, you're like, I know all this.
Nothing to add. You're doing perfect.
Okay. Cool. Okay, let's jump into the first one, and then let's just start ripping through. Okay.
Yeah.
Okay. Invalidated. Next.
Select the reason.
Oh, did I not? Oh, select the reason. Oh, so yep.
And mark it as done.
What, like other? Just nothing. Maybe we should have like a nothing. Yeah, I forgot the market is done. Thank you. All right, cool. Next, TSender on Blast lacks gas fees claiming logic. TSender on Blast lacks gas fees claiming logic. TSender is expected to be on Blast, which has a unique feature of allowing contracts to claim back gas fees spent by the contract. See here. Existing L2s like arbitrary. Actually, existing L2s like arbitrary optimum keep secrets or fees for themselves. Blast redirect secrets or fees to claimable. Interesting. Interesting. Setting gas mode to claimable. This seems like a feature.
It is a feature.
Hmm.
My first question is, do you have any idea how much revenue could this generate?
It's a good question. Well, so the this is kind of more.
Also, this would entail making a separate version of the contracts for Blast, because you
Yeah.
wouldn't want to implement this interface and the constructor in everything.
Yep.
Else it will just cost more gas on the deployment on the other chains.
Yeah. Oh, GM Anna, by the way, Anna is one of the is the designer for the Codeox, so definitely be sure to say hi to her as well too. Yeah, in all honesty, I mean this seems like a feature. This doesn't seem like a security vulnerability.
It's
What are your
not a security vulnerability.
Yeah. I mean it's a great feature recommendation, but sorry. Okay, we're on the same page. So you already peeped this ahead of time.
A little bit.
Yeah. Okay, cool. So I'm going to say design choice. This is a feature, not a security issue. I mean, it's a great recommendation, though.
Indeed.
Yeah. Airdrop ERC20 should be made payable for further gas efficiency.
Okay, but before reading this, we should have a small debate, given that you're the main developer behind the project.
Yeah, I'm
Gas
gonna.
gas findings are invalid on
Yep.
Codeox.
Yeah. Yes.
I mean, even though the aim was to make this super gas efficient.
Well,
So
so this is actually invalid for a number of reasons. Number one, yes, it's aimed to be super gas, or number one, what you just said, gas submissions are invalid. But number two, if you read the docs, like TSender, I intentionally made it not payable, right? So if you go to the TSender features, it doesn't allow ETH to be sent with function calls. Like that was a very intentional choice that was made. So not only is this invalid because it's not gas, they didn't read the docs. So double,
yeah,
I guess like double invalid.
and also if you made this payable, then you'd had a lot of issues with why there's no withdraw function for if stuck in the contract.
Yeah. Yep.
So
Exactly. Permanent locking of funds and absent contract address check. The TSender contract is designed to perform ERC20. However, it lacks mechanisms to recover funds that are accidentally sent. This is not a security vulnerability.
admin input validation or user input validation, in my opinion.
Yeah, 100%. So,
And if we were to check for this address, why not check for address? I don't know, any other random address. I know we check for address 0, but there are a lot of addresses to check for.
This is user input error. Users can do a lot of dumb. I'm not always going to write this long of a rationale out, but users can do a lot of dumb stuff. We can't possibly check for all their silly things. Additionally, ETH can't. Well, I'm just gonna do that. Yep, same page. Approval check missing from transfer from. To me, this is known. We addressed this directly in the docs. Tokens from the sender, blah, blah, blah. However, it does not check whether the sender is granted necessary allowance. That's what is their POC? Test successful airdrop with approval. Wait, hold on. Does not ensure the sender has provided a sufficient allowance to the contract transferring. It doesn't matter. The submission can result in failed transaction causing injury. I mean, of course. I mean, that's how.
Obviously, yeah.
That's how the ERC20 works. This is like known issue sounds wrong. I guess like other like this is how ERC20s work. This is known and would be a massive waste of gas to additionally check for this, since the ERC20s already do this.
I don't know if he wanted to check it or not, but I think he wants us to put the approval straight in, to cook it in the code.
Yeah,
no.
That doesn't make any sense to do. Yeah. Theft of user funds in zk-sync due to message.sender preservation and cross-chain calls. Okay, this is interesting. This is the type of shit that I was looking for. What is the community sentiment? Is it at the bottom? Most people said invalid. Okay, what are they saying? The TSender.so contract designed for ERC20 airdrop is intended to be deployed on different blockchains, including Ethereum and zk-sync. However, due to the preservation of message.sender on zk-sync for L1 to L2 calls, a high-risk vulnerability exists. This vulnerability allows attackers to impersonate other users' contract-based accounts holding ERC20s on zk-sync by deploying a contract with the same address on Ethereum. This report outlines the vulnerability, details impact, and provides recommended. Okay, so this is interesting. For the zk-sync chain, message.sender is preserved for, or this is bullshit, and I'm being pranked.
It's fun. You know what's fun about this one? Because it involves impersonation and deploying a contract at a specific address.
Mm-hmm.
And I'm sending you a link, and I'll send the chat a link as well.
Okay.
Wait a second.
This is a question that I asked almost 2 years ago.
You actually asked this 2 years ago. I don't know if I am allowed to send links in that chat, but
yeah, you can't send links on the comments. I'll drop one here. So this is the link that, in all honesty, is referring to, which is kind of hilarious that I asked this. But so let's keep reading the let's keep reading this, because it sounds like you've already done some research on this. What time is it? 9:20. We're probably gonna have to rip through the rest of these a little quicker. For the zk-sync chain, message senders preserve. One of the rules when pursuing a cross-chain strategy is to never assume that address control between L1 and L2 is guaranteed. Okay. It is generally true that any account accessible on Ethereum will also be accessible on other event chains. However, this is not always true for contract-based accounts, as the same accounts wallet address might be owned. Oh, yeah. Okay. No, this person's, reading this, I'm already sensing this is not going to be valid. For instance, if a smart contract wallet factory deployed on both EVM-based chains is determined to create two, which allows you to define blah, blah, blah. Bob, the attacker, saw this address is not owned by anyone with Ethereum, therefore he okay, they don't understand how the airdrop works.
I mean,
yeah,
how would they take ownership to that address?
Yeah, attackers consider wallet contracts. Yeah, I see what they're trying to say. Restrict access to EOAs. No, okay, so this is invalid. I mean, it was a good attempt.
Yes.
Yeah, this is I guess other when airdropping tokens to addresses, the home chain of the address is known and intentional. We don't cross-chain airdrop. We do airdrops associated with a single chain at a time. Hopefully that's clear, but good attempt.
Yeah,
no,
super decent.
Yeah. Functions may not behave as expected. ERC20 functions may not blah, blah, blah. Return values. This is known. Called this out directly in the known issues. Different versions of Solidity is used in smart contract. Solidity versions.
Okay, invalid most likely. If not, it's informational at best.
Yeah.
Still invalid.
I'm gonna do this, but it's also like, I mean, this is invalid for 100 reasons. Product may fail to deploy on chains not compatible with the Shanghai fork, blah, blah, blah. Push your opcode. Yeah, so this one's known, I guess.
Or it's just info or known, or I don't know.
Because what did we say for so because we said chain compat Ethereum after blah base blah blah blah. Which I mean, if they can prove that one of those chains, actually I'm gonna do other.
Even if they prove it, what's the impact? You try to deploy it, it doesn't work. You change the pragma, it works. Nothing is lost. That's why I consider it info.
I mean, I would argue it's low if it's well, because what could happen is if I deploy and it lets me deploy, like maybe one of the L2s lets me deploy, and then I have a push zero opcode in like I have deployed contracts with like an invalid opcode, and for some reason some chains let me do it. Like, you know, you get like a chain that like doesn't know.
Okay, but then if you try to use the function, it will still revert in the end. So you won't be able to send the funds there.
Yeah.
So you'll only lose gas fees, and if we are talking about L2, it's a very small amount of gas fees. So
I would argue I could see someone argue it as a low, but I think this is not. There's just saying, hey, like there could be one that doesn't have push zero. To me, this isn't even worth like continuing down. So base deployment TSender Huff needs a set gas mode to claimable. This is another
duplicate of 2.
Yeah. So this is, I mean, this is a great.
Yeah, it's a nice one.
It's a great recommendation, but this is non-acceptable severity. Good feature recommendation, not a security issue. Unhandled return value. This is invalid. Known. Missing events, successful airdrops. I mean, this is pretty
informational at best.
Yeah, I mean, we are going for super gas optimized. Events are a waste of gas. Lack of duplicate address check. This is known. This is intentional. Re-entry vulnerability. What?
Yeah.
I mean, hey, maybe there is. Oh, maybe there is. Contract includes 2 primary functions: airdrop ERC20 and R list valid. The airdrop ERC20 function is designed to distribute a specified total amount of ERC20s to multiple recipients. However, this function does not implement any safeguards against re-entry attacks. The vulnerability lies in the absence of re-entry guard in the airdrop ERC20. Here's a simplified version of the critical section. Sure. Proof of concept. The attack deploys a malicious contract that calls airdrop blah blah. Includes a fallback function. Re-entry blah blah. Blah 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 blah.
Yeah, that's not how reentrancy works.
It could be, but I'm going to say you'd have to prove that one of the ERC20s we are planning to use with this has this issue and causes damage. I love the creativity. Sorry. A whole bunch of questions came in. Let's answer some of these questions. Did the updraft course almost took one great stuff. Wow, first time to witness live judging. Complete transparency right here. Hell yeah. Finished Thunderloan today. Let's go. Can you please remove the link? Yep, sorry. I've tested this opcode not available, and those transactions actually revert. I'm
on which chain?
Yeah, on which chain, and I guess maybe this is where the appeals will come in. Lack of duplicate address check and tsender.huff. I mean, this is we did this on purpose. Yeah, okay. Invalid. Known issue. We called this out right in the docs. Missing event. Invalid. Events cost gas. Mark is done. It is better to implement the while loop like this. Ooh. I mean, this is invalid, but like,
yeah,
for. Oh, is this for the R list? this is also for the one like I know that function. We don't care about gas costs, but thank you. Also, gas submissions are invalid.
Yes.
Doesn't check Boolean returned. Known.
Known.
Yep. Test. Sick reason. Nothing. Yep. Nothing. Cool. Test 2. Great. Great submission here. No check on transfer. Known. Called that out right in the docs. Test 3. Design choice, I guess. Compilation of low risk findings. Okay, this is going to be out of scope, out of scope, out of scope, out of scope. I mean, these are all out of. This is probably like an automated tool.
Yes.
Yeah. Okay. What are these submissions? Denial of service vulnerability in AirDrop 20 due to large recipient list. How is this a denial of service?
Isn't this known?
Cannot be used for more than 1,200 recipients due to exceeding block gas limit. Implement a claim functionality where eligible users can claim their airdrop tokens as pro shifts the gas cost individually. No, this is a feature. This is like I'm not. No, absolutely not. Uncheck return values from call. The contract uses the call method to interact with ERC20 transfer. Transfer from ERC20 tokens functions returns a Boolean. This is known.
Known.
Yep. We call this out right in the docs. Reentrancy in transfer. TSol airdrop ERC20. But what's the issue? Reentrancies occur when blah, blah, blah. But like, what's the impact? So we have reentrancy. Okay, so this is actually good. Just for everybody watching. So in Cypher and Updraft, we talk about this, right? We want to do actually in all honesty, what are your favorite like titles of submissions? Like, how is there like a format for titles that you prefer?
I prefer them writing a title that points to the vulnerability, but not reentrancy in TSender and stuff like that. Just point me to the exact place. Tell me like, because we are using USDC and we are transferring this to that person can get blacklisted, and even though that will be invalid as well, but at least make it more specific.
Yeah. So Shakar pointed out the one that we teach in Cypher and Updraft, where we say root cause plus impact. So this is saying root cause is reentrancy, which maybe that is a root cause, but then you don't have the impact here, right? There is
also not all reentrancy is bad,
and that's the other thing, right? Sometimes people do put exactly like sometimes people put reentrancies.
I mean, you have callbacks.
Yeah. Sometimes people put reentrancies here on purpose. So maybe you say, hey, there's a reentrancy, and it's like, cool. Like, we wanted that. This is an example where we want it, but this is an example of where, cool, there is a root cause, but there's no impact, right? And it sounds like people are kind of like fishing a little bit here, which is okay. I mean, there's a lot of new auditors might be testing this out. So this is going to be, I guess, like, design choice or
you're looking for incorrect.
I mean, actually, you know what, you're right. Yeah, incorrect statement. Good call. You'd have to prove one of the compatible tokens causes some type of impact. Great. Mark is done. Next. Inefficient error handling in assembly code. Okay. The current error handling mechanism in the assembly block stores error codes in memory and then reverts. This is a two-step process that involves storing an error message or error code first and then using the revert opcode to revert the transaction. This method can be optimized by directly reverting the error message without storing it first. It can save gas. Sorry, buddy.
Invalid guess.
Yeah. Also, this I mean, so I like this attempt. And this is what the Gaslight code base does. The reason we added this in here was so that we could have this be the error code that's emitted. Without this, it's just a generic revert. But I wanted it to be a little bit more expressive, saying, hey, TSender failed. So this is invalid for a bunch of reasons. So this is going to be gas. I mean, this was intentional, and gas submissions are invalid. Cool. Lack of validation for token contract address. This is known. Or what would you put for this one?
Admin input validation.
Yeah. Yep. This is known. No event emission. Known.
Also, how would you check it?
Check event emission?
Not event emission. The fact that you're using the right contract, the right ERC20. Other than storing everything inside and just checking against that.
Well,
because if it's a contract, it's okay. It's a contract, but it might not be the right contract.
Right. Well, I would say there's an argument to be made where you, like, on certain platforms like Aave, for example, like Aave doesn't let you like deposit certain types of collateral, right? It only lets you deposit certain tokens as collateral. We could 100% have more strict checks in this code base looking for different token contracts, but I think it's a waste of gas. Yeah, it needs a lot more admin work, and we called it out intentionally that we didn't want to do this. So unchecked array access does not validate the lengths of the recipients and amounts arrays before accessing their elements. This is known.
I mean, that's what for the other function is.
Yeah, and this is also out of scope. So this is known. Also TSender. Oh, no, never mind. It's not out of scope.
That's not out of scope.
Yeah. Okay. Wait, what? It's the first thing that we do. It's also wrong. Valid lengths are if the arrays are empty or have different lengths, the contract. I mean, this is wrong, actually. Inefficient duplicate check.
No.
I know. I know. Improper order of total amount check in airdrop ERC20 function of TSender. The contract TSender has a function called airdrop ERC20, which is responsible for airdropping ERC20 tokens. The issue arises from the sequence in which the total amount of tokens is verified against the sum of individual airdrop amounts. This discrepancy can lead to failed particle. What are you talking about? Wait, the issue arises from the sequence in which the total amount of tokens is verified against the sum. This discriminate the airdrop function if the airdrop ERC20 function performs a check. If is 0 equals added amount total amount. After initiating the token transfers to the recipients, the sequence allows the total amount specified to be different than the actual amount calculated from the amounts rate, potentially into inconsistencies and incorrect behavior in the airdrop process. For example, if the user specifies total amount as 10 tokens, but the sum of the amounts array is 20 tokens, the contract will attempt to transfer specified amounts. This results in the contract running out of tokens midway through the process. What are they talking about?
At the end of the airdrop ERC20 function, you have a check. But
what are they? So check the totals match. So we have this here. This is literally the last step that we do. Is this Hawk saying this is wrong? This discrepancy. Or are they saying what? I don't know. I don't know what they're saying.
How can there be partial airdrops? Because if you run out of balance, it will revert.
I think this is wrong. I mean, they would need to prove that. Yeah, I'm going to say wrong. Prove that the check at the end is wrong with a POC. Otherwise, this is invalid. Now, here's what they're going to go try to prove it with a POC. They're going to come back, realize it doesn't work, but they're still going to try to appeal it. If you appeal this and your POC doesn't work, or you think your POC works and it doesn't, I'm going to be upset because you're digging there. You're digging there.
Info.
Missing NAT spec. Yep. Info. Protocol doesn't work with rebase token. Known.
No.
Potential out of gas air due to unbound array parameters. This is, yeah, I mean, this is gas. Yeah, I mean, yeah, no. Potential denial, no. It's just.
It's a view function that.
Right. USDC and USDC transfer to blacklist address block the airdrop.
Known.
Yeah. Yep. Good try. Do we actually call that out specifically?
I think we did. Yeah. Upgradable denial list tokens can prevent this contract from working.
Yeah. Emit events. No. Gas bad. Protocol won't work with known. Gas limit considerations. The function iterates over arrays before it's going to be gas. Known. I mean, yeah.
Yeah.
Incorrect duplicate check. R-list valid. The inner loop starts from 1 and not 0. That means that this is because the first inner element skipped. I don't
no,
think.
It's actually, it starts from first element is 0, yep. Then the second is 1, and you compare against one another. And
yep. The first element is 0. The second is 1, and in the inner loop, you want to start with the 1th element to
also called first.
First to the 0th. Yeah, first. Yeah. Look at that. We're almost halfway through. Wow, we're ripping through this. Force receive ether lock forever.
Okay, if you want
to. So somebody messaged me this on Discord, and I was like, yeah, like this is true for all contracts. This is. I mean, this kind of sets like a higher precedent of like, oh, you didn't say self-destruct, haha, you idiot.
Yes, and at the end of the day, everyone can send their if to address 0.
Yeah, I mean,
if that's what you want to do with your money, just
if you want to screw yourself out of your ETH, I mean, like you have to try really hard to, you know, like if you're deploying a contract with a self-destruct just to like, no. An uninformative error makes it difficult to work with the protocol. When certain tokens, blah, 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 blah. The error should be contained information, but no.
Info.
Thank you for the suggestion. Denial of service attack, blah, blah, blah. The denial of service when the value raises, when the larger raise, blah, blah. Recipients for iterating, blah, blah. The gas required to complete the functioning, blah, blah, causing the transaction to revert.
I mean, it's a user action. If you are going to use this to send the code hawks rewards, for example, you are aware of this, and you will send enough, but not that many, so it won't fail.
Well, because what's the recommendation to prevent these issues and ensure reliable and efficient token transfer? It is recommended to implement batch processing for TSender. I mean, you can already do that just manually.
I expected them to recommend the maximum length for the array, maximum array length, but they didn't.
Right.
Even though that would have been invalid.
I'm going to say like design choice. Users will manually chunk the arrays. Proxy pattern usage.
Okay.
Informational. This is a design. Approve. Actually, you know what? Let me see. Oh, it's super generic. Approve function can be front run and use the coins for airdrop maliciously.
How?
Approve. Perform efficient tag transaction. Blah, blah. Okay, what's their POC? Okay. Prank sender, mint, approve. Recipients can be changed easily to create new malicious lists. Malicious users already know how much the amount of cases approved.
But how would they gain access to the list?
Yeah, right. So this person is saying, you're saying a private key holder is going to front run themselves. That doesn't make sense. Unless you're saying if they have exposed their private key, then they can get front run. Well, if they have exposed their private key, a good hacker would just transfer out their funds and could approve themselves. Anyways, that kind of explainer was probably overkill, but cool. TSender contract assumes it's interacting with externally owned accounts as recipients. I don't think it does. The behavior comes unpredictable. No, it doesn't. Wrong function of the user content is called transfer function. Well, how the recipient smart contract to function was for the token not transferred. This is no. It's just wrong, too generic, insufficient allowance. No. Oh, whoops. Mark is done. Non-standard WETH behavior on Blast L2 contract caused denial of service in airdrop contracts. Okay. The WETH contract deployed on Blast L2 chain does not conform to the standard WETH 99 implementation. The WETH contract deployed, okay, so it lacks the following allowance check in its transfer from function. As a result, any attempt to use transfer from with WETH on Blast L2 will always revert. Vulnerability details. In this airdrop contracts, the transfer from call is used to transfer. Implement custom logic for WETH transfers. Because
I've sent you the contracts.
Okay.
Also, I mean, this one was first caught on Chainlink audit, I think, and it won't work like that. I mean, both in Chainlink and in another one, I think was Abracadabra exchange or something like that. That was another audit on another platform. It has something to do with contracts sending to other contracts with on blasts using transfer from, and the fact that they are sending from their own address to another address using transfer from would the approval check would be skipped in mainnet, for example, but in blast they don't have that check.
So what are you saying? So are you thinking this is valid?
No, this is invalid because you will use an EOA.
If allowed does not equal max allowance from. Wait, so what's the issue?
The issue is what's missing from that contract. Click the other link I gave you. It doesn't take you.
It's all right. I got it.
See, here it's checking the source. If the from address is message.sender, then it skips all the allowance check.
If source is not equal message to sender, an allowance of source is
Not
max.
infinite, not max.
Require allowance of source to be greater than WAD. So we're missing. So what's the. Okay, so we're missing this. As a result, any attempt to use a transfer from with WETH on Blast L2 will always revert. Why will it always revert, though?
Let me give you an example
Sure.
of a valid one. Let's assume you have a contract where you, as the user, can call, and it has a payable function, and you send some ETH over. That ETH gets deposited in the WETH contract.
Mm-hmm.
The contract you called receives some WETH from the WETH contract, and then transfers from itself to another contract the WETH you just put in. Let's say it creates a pool or something like that.
Sure.
Because it's transferring from its own balance using transfer from to another contract, it should be okay. And it would be okay on mainnet because the from corresponds to the message.sender in that case.
Mm-hmm.
That doesn't happen on Blast because they miss that check, that half of check that's available on mainnet. It's not available on Blast. That SRC different from message sender.
If source does not equal message sender.
If that one is false, so the SRC is equal to message.sender, it jumps over the whole allowance check.
Right. So if source is message sender, it jumps over.
And just perform the transaction.
So
in here, it doesn't.
If source.
So you have to explicitly approve a contract to spend its own balance.
Yeah. I mean, that makes it won't revert then. It'll just work normally. I don't understand. Is there an issue here? Like, it doesn't sound.
It's not valid here.
It sounds like, if anything, that's actually better. It's like slightly safer.
It is slightly safer, but it's also not how it usually works.
Right. So they're saying their impact here is wrong.
Yes.
Because this, it won't revert. It'll actually work.
I mean, first of all, you'll be using an EOA.
Yeah. Okay.
And you'll approve, and everything will go through. But again, this one was one of the best ones.
This is yeah.
It was a nice try, and also, I mean, Hawks should write this one down.
This one is pretty cool. Actually,
it's a sneaky one.
It's invalid, but it's cool. Like, I mean, because like the thing is, if they wrote like a POC here, they would have found right away. Oh, like you just approve. Like, I guess the argument here is like on ETH mainnet, you don't need to approve, and on Blast, you need to approve, right? Like
Yes.
that's the difference. Yeah. An array's length should be cached to save gas. No. Out of gas risk in multi-recipient token trend. None of y'all been going into the huff, huh? Y'all staying safe with the Yule. Weak. Out of gas risk in multi-recipient token transfers. Out of S. No, this is just weak sauce. I don't know, like lack of quality, maybe like weak sauce. Smaller bet. No, design choice.
No. It's a design choice. Let's be nice.
Yeah, user will manually chunk lists. USDC does not return value. Known. Possible out of gas. Wrong input of gas. Use of gas is not optimal. In both calls, gas is used to specify gas limit for the given call. However, using gas means the call will consume all available gas up to the block gas limit. If a function makes multiple calls using gas to set the maximum available gas, it can potentially exhaust all the gas. Wait. However, using gas means the call will consume all available gas up to the block gas limit. Function makes multiple calls using gas to set the maximum available gas. It could potentially exhaust all the gas. No. Need POC. You'll find out this isn't the case. Protocol will not work with ERC20s that revert on zero amount transfer. Check. We actually have a zero amount check, actually.
Indeed.
So this is like wrong, known, not true.
Also, I don't know about the tokens we are actually using in the protocol.
Yeah.
I think BNB is one of those, but not these four.
TSender features, blah, amounts. Okay. This is like known. Also, we handle this with the, what's it called? R-list valid check. R-list valid. Lack of safe transfer checks is known. Duplicate address vulnerability in airdrop ERC20 function of TSender contract. The TSender contract includes an airdrop ERC20 function designed to distribute ERC20 tokens to multiple recipients. While the contract has an R-list valid function check for duplicate address, the address is missed, blah, blah, blah. It does not enforce a duplicate check. Then this is design
choice.
Yep. Same page, in all honesty. Airdrop function is not compatible with USDC if decimal format is wrong. What?
How can that be wrong?
We don't do anything with decimals. In this code. Supposed Huff replica of the Gaslight contract is missing a check. Okay. Well, it's
that's the whole point of having a no check.
This is the no check is the no check edition. Yeah, design choice. The no check is the no check edition. with no checks. Missing check for blacklisting. Known.
Known.
Yeah. Okay. Product may fail to deploy change not compatible with Shanghai fork. I mean, I like this. Okay. Current settings, blah, blah, blah. This is due to blah, 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 blah. Bytecode, blah, blah, blah. Shanghai, blah, 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 blah. Yep. Okay. See, like,
I wish they mentioned one chain.
yeah, it was like, it's like, okay, this is what I was looking for. And then they like just like dropped the ball at the finish line, you know what? Because I mean, maybe they also like were like, oh, let's just do this. And then maybe they did look at the chains and then they went, oh shit, wait, never mind, it works. But let's like submit it anyways.
It's reminiscent from when Arbitrum was not working with push 0.
Yeah. So not quite, buddy. Incorrect handling of total amounts. Okay. I'm into this. The macro checks if the total amount specified in the call data matches the sum of the amounts array. Oh boy, we're into the huff now. Oh, I'm excited. Okay. However, the logic to sum of the amounts and compare it to the total amount specified is not explicitly shown or may be incorrectly implemented. Sweet Lord. Please format your code.
Yeah, especially Huff.
How am I supposed to read this? Okay. However, the logic of some of the blah 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 vulnerability details. I don't know. I guess I'll check that later. However, the amount's starting location may be different depending on the number of recipients. Check if the number of recipients matches the number of amounts. Check if the number of recipients matches the number of amounts. Is this the Huff code?
He's referencing the Huff code.
Is this the no check or is this the this is the Huff code with the checks? I think we do. Oh, I think that's where they lose it because we do a check. Oh no. Oh wait, whoa. This is the R list valid. Because they're saying the R list valid is wrong. Okay. However, the amount starting location may be different depending on the number of recipients. Check if the number of recipients matches the number of amounts. Do we not check that in here? Recipients length offset. Recipients lengths. Dupe one. Check if the number of recipients is 0. Okay, so we check when the number of recipients is 0. Do we check the two lists have the same length? However, sorry, blah, blah. Check if the number of recipients matches the number of amounts. Okay, so wait, so what is this person saying? They just copy pasted all the code here. I was so excited, and then they just straight dropped the ball. This can lead to scenarios where total amount transfer does not match, blah, blah, blah. Ensure that each recipient has corresponding amount in the amounts array by checking the lengths and contents of both arrays more thoroughly.
Let's call it vague.
But... well, what is you're gonna make me pull up my VS Code. Just so I can read this, because maybe this is something that I'm like totally missing. Okay, do I have to share my other screen now? Stop sharing, present, share screen. Let's look at this one. So this is their what they submitted. Let's call this oops. It's fine. Scrap dot Huff. Okay, cool. The recipients will always okay, because this is what I want to read, right? The recipient's starting location will always be OX44. Recipient, blah, blah, blah. Okay, these are their comments. The recipient's starting location will always be 0x44. Call data load. Recipient's starting location will always be 0x44. So are they saying the recipient's starting location? The macro checks if the total amount specified in the call data matches the sum of amounts array. However, the logic to sum of the amounts and compare it to the total amount specified is not explicitly shown or maybe incorrect. So they don't know. They're just kind of like, they're kind of guessing at the huff here.
Yes.
Yeah. Okay. So they're not sure how the got it. Okay. So
also, you're checking it fine.
Yeah. I wanted to just be able to read that comment though, just to like know if I was, you know what I mean?
Also, I think these are your comments.
Oh, are they? Maybe they are my comments. This is
if you open the GitHub, they.
Oh well, it is my comment, Lamau. So okay, so this is invalid for
incorrect.
Incorrect.
Or lack of quality. Or
lack of quality. Like, what is this person saying? All right, back to the quick ones. Known. No known is not defined as pure. No, or non-acceptable severity. Wrong or misleading comments.
Info.
Yeah, but I want to know what the comment is. Recipients dot offsets actually points to recipients dot length offsets, not the first address of the array offset. Unless I'm not understanding correctly, this comment is wrong. Recipients dot offset points to recipients dot length offset. Yeah, now I'm curious though. Recipients dot offset actually points to the recipients dot length offset, not the first address. Recipients dot offset actually points to recipients dot length offset, not the first address of the array offset. Recipients dot length not the first offset. Yeah, I mean, my comments are a bit confusing. I think that's fair, but invalid. Missing potential. I mean, this was probably the best.
Yes.
The best one. Good
this
feature.
And the one with web implementation on Blast.
Yeah.
The winners.
Yeah, those are like the push over pull strategy. No.
Design choice.
Or yes. Yeah, design choice. Yep. Loop because design choice or known or whatever we want to put here. No. Won't work to addresses with incorrect format. Our list valid is used to check the correct blah, blah, blah. However, not included here is a mistake in input like wrong format addresses, e.g. wrong length. This checking can easily be bypassed if the list is huge, like 10,000 addresses. Case of a function attribute sort of 20, the blah 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 blah. This.
So basically, you'll input a 10 bytes address or something truncated, or I don't know.
So you have found a way to have an address that is smaller than a uint 160 or of different size. Not sure how this is possible. There is only one address format. Am I Am I crazy? I
No.
get actually. No, this wouldn't even work. So in ZK Sync, there are addresses that are different format, but I mean all of our code, we don't do any like slot packing here, right? Everything is just treated as
Yeah,
like 32
everything.
bytes.
Yes,
So
it will be
yeah.
padded. And
Yeah. So like even if it's like slightly larger than a UINT 160, it actually would still work. Unhandling return value transfer function known. All right, wait, I'll take a second to look at some of the comments. Yeah, so somebody in the comments said something that I thought was quite good. They said, hey, now I understand why judges don't even look at my submissions. And yeah, like, so this is why it's so important to do your proof of codes, right? So that you actually know what your submission is doing. You want to write titles, in that format, kind of like what, All Honesty was saying, or Shakur was saying, like root cause plus impact. It needs to be very obvious. Hey, this is an issue because, so this is a smaller contest with only 110 submissions, right? But there's like I've judged contests with 2,000 submissions, right? And after submission, 1,000, like it's like if I see, hey, like here's a gas improvement for the 15th time, move it. I'm like 2 seconds and then on to the next one, right? So
also take care of how you phrase things. Don't just use weak language. This may
yes,
result in. Tell me this will lead to stolen funds.
yes. If you are doing a submission, spot on, in all honesty. If you're doing a submission where you're like, this could potentially do something, you as the auditor need to do the work to figure out, here's where it will impact something. Otherwise, you're going to be invalidated, right? So
Most of the time.
most of the time. Yeah, most of the time. It's harder to audit Beanstalk. Yep. I found a vulnerability of kind of blah, blah. I'm just reading the comments now. See if there's any. Oh yeah, the death trick, death.net. So like an Etherscan, BlastScan, pretty much any Etherscan compatible blockchain, you just take the .com or the .io and just swap it out for death.net, and you get opened up into like a VS Code, browser, which is pretty cool. Another one that I use a lot now is Forge. Maybe Foundry, like maybe a month or two ago, came out with Forge Clone, and I use that a lot as well. Allows you to like clone. You've used it too, in all honesty.
Yes, that's a cool feature.
Yeah. There's only an issue if transfer from is used internally as sufficient allowance. Yes, the stream will be saved. Yeah, these have been some pretty interesting invalids. Can I learn Web3 without knowing anything about programming? Yes, go to Cypher and Updraft. Oh, yep, Equius got you. Yes, the comment is wrong, but it's handled nicely. Ah, thanks. Yeah, invalid, but thank you for pointing that out. Blast gas refund is something I validated as low. I can see why somebody would do that. It's not a security issue, but it's definitely a nice feature, and that's the kind of yeah, that's just kind of the nature of like the competitive audit, right? It's like, yeah, that's something that we probably should implement, but it's not a security issue. So for the contest, it has to be invalidated.
I think they could argue for missed revenue on your behalf, but it's still an informational.
Yeah.
It's an optimization.
Yeah, this is actually the kind of like the subtle difference between like a private audit and a competitive audit too, where like a private audit, they can kind of like give you feature tips as well. Whereas in like a competitive audit, you can't, right? Because it's not really fair to have features be in scope. But a private audit, I mean, they can tell you, whatever, you know what I mean? In blast documentation, both made are considered as valid, and adding this feature will increase gas consumption. You're not sure you won't spend more gas retrieving this gas. That's a good point as well. They actually, none of the submissions proved that we would not. Yes. None of the submissions prove that it would save gas in the long run, right? Nobody wrote the huff to prove that adding this function to withdraw gas would be efficient. I have no idea what's happening here because I'm still in the blockchain basics course from Cypher. Cool. Well, this is what you have to look forward to. Keep learning, and you'll get there. Will I be able to
aboard.
Yeah, welcome aboard. Yeah, welcome to Web3. Yeah, thanks. In all honesty, will I be able to understand it after finishing the whole course? Yeah, actually, get to the security auditing course. Absolutely. How is exceeding block gas limit a design choice? All right, so maybe that was a bad invalidation rationale. It definitely isn't a design choice, but it's like a known. It's like there's a list of known issues that are like, all right, like obviously that's not going to work. Like the self-destruct thing, it's like, okay, like obviously, like anybody can force ETH into a smart contract. Like we know that. Yeah, if we have like a massive for loop, like obviously it's not going to work. So just like the user would just chunk it up. It's not a big deal. Anyways, cool.
Moreover, any type of funds won't be lost.
And that's the other thing. It'll just revert. It's all good. So I will just leave a cat here. Okay, thank you for the cat. Nobody went. I was really hoping people would go deeper into the huff because I feel like that's really where I was nervous was the huff, but it seems like nobody really went into that. Loop inside loop with no constraint length may make this function unusable by other contracts. Loop inside loop with no constraint length. Very costly.
No.
This is gas. Known. Let's see anywhere known. Called this out directly. Known. Oh wait, did they say? Yeah, we called that out. Yeah, done. Re-entry vulnerability in TSender contracts. The TSender contract, blah, blah, blah. Yeah, what's the impact? Stealing tokens, blah, blah. Okay. The impact, steal. This is wrong. Check. One, check the ERC20 token compatibilities. Number two, how would this steal tokens? What's their POC?
I mean, the only thing that has a callback out of those four is link. But in order to access the callback on the link token, you need to call another function, not the transfer or transfer from. So
this is wrong. Data corruption might occur. Okay, there's several problems with arbitrary call data in the airdrop ERC20 function within the TSender contract. Here's a breakdown of potential issues. Okay. The code currently assumes a specific format for the call data contained in the function signature. Yes, followed by arguments. If arbitrary data precedes this expected format, it could disrupt the logic within the function. This might lead to unintended consequences, blah, blah, blah. Buffer, blah, 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 here, blah, blah, blah. Input validation. I mean,
sounds a bit like ChatGPT, but we don't have enough evidence.
I mean, this is like if this is summary. This is gonna be mean. If you send the wrong inputs, you'll get the wrong outputs. Yes, of course. If this code base intentionally doesn't check call data formation. Call data format.
Thing.
What's up?
No, nothing.
This is user validation error. The flaws lie in the calculation of the end index for the loop iterating through the recipient's array. Okay, interesting. I like the title of this. Okay, this actually is a chunk of code that I wanted people to look at. Incorrect end index calculation. The line let end. Okay, the line let end. Sweet Lord, this is formatted so hard. Calculates the end index by shifting recipient cell length left by 5 bits. Yeah, okay. And adding to the recipient cell offset. The intended purpose seems to be calculating the memory offset, the last elements of the recipient's array. The problem lies in the shifting operation. While a single address occupies 32 bytes of memory, shifting recipient cell length by 5 bits only multiplies it by 32 if recipient cell length is guaranteed to be multiple of 32.
Why? That statement. Why?
But shifting only multiplies by 32 if recipient cell length is guaranteed. It is. Well, it is guaranteed. It's going to be 32. It's going to be 32 bytes. Has the remainder when it's divided by 32. Wait, whoa. While a single address occupies 32 bytes of memory, shifting recipient cell length by 5 bits only multiplies by 32 if recipient cell length is guaranteed to be multiple. Yeah, wait. Yeah, why? But this, in cases where the recipient cell length isn't a multiple of 32, the calculated end index will be incorrect and would need a POC. To generic would need a POC to prove this finding. Like this is the type of finding I wanted people to find, but then they were like, "Oh, cool, that code looks a little weird. Let's just throw it into a submission." You got to prove it. Known issue. Function doesn't assume failed transfer. Known. Token address never validated. EUA will lead to success of the function. Token address is not validated. This is known. What do you think? I think this isn't.
We already decided on this one before. It's admin input validation. We trust you will put the right token address there.
Right. I mean, that's why we have the ERC20 compatibilities section. Could lead to DOS attack. No. Can lead to contract having. Can lead contract to have an ERC20 being withdrawable by anyone. What?
Okay, you're not checking the total amount against what was sent, but it's the no check version.
When total amount transferred to the contract does not match the sum of amounts set to recipients. Since the total amounts is not checked, anyone can steal the remaining balance by settling total amount to 0 and doing themselves as the only recipient.
How?
Let's see their POC. Okay, I like this. Make address sender 100. Expected total amount equals 1 times number of recipients plus 1. So we're going to mint the expected total amount. Approve TSender. New. Okay, so we're going to make what is number of recipients?
100.
Okay, so we're gonna make 100 people, and then we're gonna do UN 256 amount. What is the UN 256 amount? Is 1.
1.
Okay. Recipients amounts, expected total amount. Airdrop. Okay. Contract has a state. Is this for the no check? Oh, I mean, yeah, it's the no check contract. Contract has a state. Stealing recipients, just stealing amounts. Stealing amounts 0. Stealer. Actually, will this work? I mean, that's kind of cool.
It is cool, actually.
Would this? Oh, because we have a no check. So yeah, so this would work. Yeah, I mean, this is. I would say this is the this is a cool finding. Sorry, hold on 1 second. Sorry about that. This is I think this is the coolest finding, but it's
in the no check contract.
Yeah. This is in the no check contract that has no checks. I mean, I love how they called it out. Like I see what they're going for here, but
I mean, following that argumentation, you could argue for every one of
every
checks.
They're basically like, hey, I know this has no checks, but like, what if
this one is really important?
Yeah. Senders or contracts can be yes. That is, we want that. Senders or contracts.
I mean, we don't want the contract to be included in there, but it's an user input validation.
Yeah.
You wouldn't be able to retrieve that balance if you put the address of this contract inside the array.
Yeah, I think this was a conversation that we had. I mean, it's still going to be valid, but this was one where we thought about adding that in here, and then I was like, I'm not adding it in because I mean, I could check for the 0 address, and then I could check for this contract, and I could check for the sender, and I could check for Vitalik's address, and I could check, I could yeah. We intentionally decided not to do that. Lack of total amount validation in our list valid function.
It's validated in the other function.
If sum of amounts is bigger, than total amount, will return true if sum of amounts is bigger than total. Missing validation of total sum amounts will return true if the sum amounts is bigger than total amount. The function will return true if sum amounts is bigger than total amount. Total sum of amounts is invoked with bad parameters. It will revert because it hit the check below. Actual amount does not equal total amount. We can avoid this by simply removing the check from here. Moving the check. By doing so, we avoid the transaction reverting and save some money. So this is kind of a gas.
Good optimization. Yeah, it's.
So this is something Alex and I went back and forth on. Actually, we ended up deciding we wanted to keep it in for the checks, just because, like, duplicate address, 0 checks. There's at least one recipient. All amounts, length of. So we don't do the check on amounts. Check. What do the docs say? Recipients, no. No. Total amount parameters. So yeah, so this is in the TSender. This isn't in this one. I guess we could add it in there. I mean, invalid. I really like this one though.
It's a good optimization, but still an optimization.
Yeah. Invalid, but I like this submission. Basically, they're saying, hey, this should be down here. Yeah, no, I think it has to be in the airdrop function. Redundant zero address check in airdrop ERC20 function, and the TSender kind of performs redundant. This redundancy results in necessary guess. The contract contains two separate. That's not how it works. Redundant length check. The TSender contract performs redundant checks. No, that's fine. Potential flaw in the time complexity of the duplicate recipient check within the R list. Actually, what do the comments say? Wait, but impact is real since funds would be stuck on the contract. Thought it was one which could be valid. Which one was this?
I think it's the one it's recommended on to perform the total amounts check on the no check version.
Yeah. So funds contract address is recipient.
Or that.
Contract address is in recipient, but impacts since no. So it's. I mean, it's the same thing as sending funds to an externally owned account with where nobody's mined the private key. You know what I mean? Like it's fine. Yeah, it's like, hey, like funds could be potentially, and this is where like, oh, we got to check for this address and this address and this address can be a little overkill because like, yeah, like, I mean, if we wanted to go super crazy, we could also say, oh, we shouldn't send airdrop ERC20 tokens to any address that doesn't have a history of transactions. And now we have to check for every single address that doesn't have a history of transactions because like, none of them are real. The other one about stealing ERC20 in the contract had an interesting recommendation though. I mean, same thing as what in all honesty just had said, like, oh, it doesn't have any checks, but like this check is really important. You know what I mean? Yeah. Potential flaw in the time complexity of the duplicate recipient check within our list valid function. There's potential flaw in the time complexity of the duplicate recipient check within the R list valid function. The function utilizing this loop to blah 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 blah. Yeah.
No.
Insufficient checks for recipients in R list valid can cause funds locked if recipient is address this. I mean, we just went over this, right?
Yes.
Yeah. Incorrect implementation with respect to documentation in some parts of the code. In Hoffers and diff. Okay. The implementation of the Huff code is not the same as competed, nor the same as the sole version of some parts. In Huff version, diff is desired to be calculated using the same formula that the sole version, which is recipients dot offset minus, and it is commented to be the way, but it's not the actual code implemented as a Huff code. It's retrieving diff by subtracting array links offset. However, the sole version gets diff by subtracting the offset of the first array of elements in both arrays.
I wonder what's the impact.
Array.offset and UL gets the pointer of the first element of the array. And as we can see, impact confusing and misunderstood. See, it's not, there's the impact is none, right?
I mean, as long as the code works, that's good. Okay, it might be different, but
I mean, I like this submission. It's this contest kind of feels bad because I like this submission, but yeah, I mean, it's invalid, but I like this submission. Nobody had any ZK sync submissions. That was the other thing that was kind of disappointing to me.
I expected the blast submissions.
You did? You've seen those before? Blast was actually a last minute, like, I kind of threw it on there because I was like, shit, I don't think anyone's going to find anything. I don't really know anything about Blast. Let's just throw that on as like one of the chains we're going to deploy to and see if people find stuff.
I mean, we still have some to go, so maybe there is something.
As we can see in the code, but puts no impact. I mean, this is a great because I love that this person submitted this, but it's
a strong information.
Yeah, which feels bad. Sick. Doesn't check if both arrays are not empty. I think that's fine. Or do we do that? Does not check if they're empty. Do the docs say it checks if they're empty? No. This would be another informational.
Yes.
Okay, I like this. Due to a mismatch of hard code and dynamic call data offsets in the TSender.huff and TSender.huff, both contracts transfer funds to incorrect addresses when called with specific call data. Huff code TSender.huff, TSender.nocheck.huff. Hard code certain call data offsets, e.g. recipient 1 offset equals 0x4a. However, the offset of dynamic types like arrays is not fixed in call data, leading to incorrect code execution. I think this person's going to be wrong, but I'm excited for this nonetheless. What are they saying? Recipient 1 offset. So recipient 1 offset is this, which is cast to base decimal 164. And I'm pretty sure I have an example here where it's always going to be 164 because these, yeah, it is always going to be 164. Like how are they going to prove to me that it's not? However, the offset of dynamic types like array is not fixed. Call data leading to incorrect coding. The current ABI encoding used by Solidity and Viper does not enforce a fixed order for dynamic type offsets.
I wish he provided the source for that.
Oh, because that seems like a big thing, actually. As a result, both call data examples below are valid and decoded equivalently by the reference and UL contracts. However, while call data A works as expected in Huff contracts, call data B results in transfers to incorrect addresses. This is the type of shit that I was looking for. Okay. All right. In all honesty, before I go deep into this, did you validate this or invalidate this?
I actually plan to ask the sponsor for this one.
Nice. Oh, that's me.
I couldn't find the source for that. Basically, in call data A and call data B, he's scrambling the amounts and recipients.
Yeah. I love this. Yeah. Sorry. Go ahead.
Can this happen?
I don't know. I'm excited to find out. At a specific point in the Huff code, the difference between the recipients. So basically they're saying. So I have it hard coded that.
Yes,
yeah.
The order is hard coded, basically.
Yeah, the order is hard coded, and they're saying that's not the case. At a recipient point in the Huff code, the difference between recipients and amounts array offset is computed for further use. However, due to recipient blah blah blah, this difference becomes zero. Wait. However, due to the inversion of the recipients and amounts array offsets and the use of the hard code blah, the difference becomes zero when call data B is fed to user. Check this scenario in the EVM playground. Copy the link. Is this the right? Yep. Oh, I'm into this shit. Wait, fuck, I ruined it. I thought it would turn into the, oh shit, bytecode. There we go. Mnemonic. There we go. Okay. Consequently, this difference is subtracted to obtain the correct offset of the current recipient element in the recipient's array. The wrong offset is used. That's the blah blah. See the POC below. Note the Huff context or blah blah blah. Okay, so this is what we're gonna try. Before we try this, I have to pee, so I'm gonna be right back. 1 sec. Put up the fun little starting soon thing. Sorry guys, give me a minute. Sorry about that. In all honesty, how are you feeling, man?
Welcome back. All good. I'm actually looking forward to see how we judge this one.
Yeah. All right. I'm gonna turn these lights off because they're killing me here. Okay. I think it's gonna depend on the POC. What time is it? Oh shit. What time is it, by the way? Do I have a meeting anytime soon? No, I don't. Yay. Okay. Yeah, me too. This is kind of fun. So basically, Right. If we mix up the orders, it's going to be an issue. That's the current amount value. There's a current amount value at this offset is incorrectly used both as the amount and the recipient of the blah, blah. Right. Okay. See this view POC below. Note that the Huff contracts are not equivalent to the reference or Yule contracts. Although the same call data is used to call all three contracts, tsender.huff and tsender.nocheck.huff, transfer tokens to the wrong recipient, add the following code to the test folder, and run it with forge test. Oh my goodness. Okay, here we go. Well, we're going to run this. That's what we're going to do. And I'm going to share my screen. We're going to go over to this. Oh, shit. Come on. Okay, let me switch. Yeah, this is a good question. Like, how true is this? Okay, so this person said we should take this, add it to the test folder. So let's go ahead and do that. Actually, let's turn this off. Let's turn this off real quick. Forge build. Oh, what make file or what do I do to get started again? Is it just make? It's just make. Yeah, let's just do make. Yeah, there we go. What the hell is it doing now? Make, move, install, build. Forge build. Oh, that's why. Okay, cool. Okay, and now I can do forge test. Oh yeah, because I disabled FFI. Yeah, that's fine. Okay. So now, actually, let's just test like forge test dash. How do I check the contracts again? Match path. That's what I want. Forge test dash match path reference or no match contracts reference, and this should work because it should just do the reference tests. I just want to see that tests in general work. Great. Okay. Cool. So now we're going to copy this over. Where do they want me to add this in? They want me to add this into the test folder. Okay, so
a new file in test folder.
What's up?
A new file in test folder.
Yeah, hawk poc.t.sol. Paste it in here. Let's see what we're working with. TSender reference setup. TSender location. Huff deployer. Is there anything malicious in here? VM dot. No, it doesn't look like there's any. So it looks like I'm safe to turn FFI back on.
Remember these people.
Yes. Yeah, I remember this.
Do what he does.
Okay, so what are they doing? Test call data A. Jesus. Oh, well, okay, so they're just hard coding the call data. Okay, so this POC actually isn't that helpful after all, because obviously with different hard coded call data, it's going to be different. So yeah, actually this all hangs. So yeah, I guess I should have looked at the POC before, because this all now hangs on this sentence here. The offset of dynamic types like arrays is not fixed in call data. Or the current ABI encoding used by Selenium Viper does not enforce a fixed order for dynamic types. What version of Solidity? 0.8.24. Dynamic arrays. Array data is located. Blah, blah. Okay. Mapping and dynamic arrays. Due to their unpredictable size, mapping and dynamic array size types cannot be stored in between the state variables preceding and following them. Instead, they are considered to occupy only 32 bytes with regard to the rules above. So this is storage, but I want call data. Layout of call data. Here we go. The input data of a function is assumed to be in the format designed by the ABI specification. Among others, the ABI specification requires arguments to be padded to multiples of 32 bytes. The internal function calls use a different convention. Arguments for the constructor of a contract are directly appended to the end of the contract's code, blah, blah, blah. Cool. That was it. That was the whole section. Okay. Function selector, argument encoding. Starting from the 5th byte, the encoded arguments follow. The coding is also used in other places, e.g. the return value, and also event arguments are coded the same way. Without the 4 bytes, now that I'm reading this, I'm starting to think this is probably invalid. Just because, like, why would the encoding order not be the same? Like, what? They were like, hey, like, if you decode it, they decode the same way.
Why would they scramble it?
Why would they scramble it? Oh yeah, let me check their POC again. Do they ever like, maybe there's like an ABI encoder version or something that they use to like change the order? No.
I mean, as long as they hard coded them.
Okay. Following element. Okay, so it says the encoding arguments follow. The encoding is also used in other places, e.g. the return value, blah, blah. Okay. So we have unsigned integer type of m bits. Sure, whatever. Okay, the following fixed size array type exists. We don't use fixed size, so we use dynamic. The following non-fixed size type exists. Bytes, string, type array. This is what we're using. Types can be combined into tuple by enclosing them in parentheses. Blah, blah, blah. It is possible to form tuples of tuples, mapping solidity to ABI. Design criteria for the encoding. Reads necessary, blah, blah, blah. The data, blah, blah, blah. So what they're saying is, so these first two, offset recipients, offset amounts, they said these could point to different ones. But I don't think that that's true. I think they will always go in order. Types are static. Length of A. Okay. The following types are called dynamic, but we need something on the order. Function selector argument encoding. A call to the function f with parameters a1 blah blah is encoded a function selector encode a1 blah blah the return value blah blah blah. Examples given the contract bytes memory bool. In our foo example, if we wanted to call bar, so let's look at Sam, right? Sam is the one we want to look at. If we call bar, if we call baz, wanted to call Sam with the arguments Dave, true, 1, 2, 3, it would pass 292 bytes total broken down to method ID is derived from signature, blah, blah, blah. The location of the data part of the first parameter, dynamic type, measured in bytes from the start of the arguments block, in this case, 0x60. The second parameter, Boolean true, the location of the data parameter, the third type, measured in bytes, in this case, 0x0. The data part, I almost feel like we have to go to the freaking Solidity compiler. Use the dynamic types. I call the function blah, 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 with values, blah, 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 as encoded the following way. You take the first 4 bytes of this. First, we encode the length and data of the first embedded dynamic array of the first root array. Number of elements in array 2, 1 and 2. Then we encode the length and data of the second embedded array 3 of the first root array. We need to find the offset A, B, or such array, blah, blah, blah. Offset A points to start of the content. Thus, I would have loved to see a slightly better proof of code here. Count for 1, 1, count for 2, 2, count for. I don't see an example where they're out of order.
Yeah, me neither.
But you know what I do want to check is, yeah, it looks like, it looks like the docs probably aren't going to be helpful for us here. So what I do want to check then is they made a point here. Both call data examples below are valid and decoded equivalently. I think that is what I would have liked to have seen decoded equivalently. So let's decode them. I think that's a play, because, and I think this would be a valid if this is the case, because if they are decoded equivalently, if you go let's say you were validating your call data and you validated the call data using ABI decode and it says, yep, that's good. Then I would say, oh, well, the user, I don't know. I would argue that's probably the user could validate it. Solidity says it's valid, and then you do it and it's not valid. I would say that's a smart contract issue. So let's pop into Chisel. Let's do that. So Solidity docs weren't helpful here. The Hawk, I didn't love their POC, but we're gonna see what we can do here. So let's grab their 2 call data examples. So this is 1. So we'll say bytes memory call data A equals hex this, and then call data B. So first, and then bytes memory call data B equals hex. And then are these actually different?
Yes, they are.
They are different. You can see that. Oh yeah, okay. I can.
They end differently.
So call data A, call data B. So these are different. Now we should see how do we decode these? Do we use chisel or do we use cast? Is actually cast the better? So cast. Actually, yeah. Let's use cast. Call data. ABI encode. ABI call data decode. Decode the okay. Cast call data decode. Sig call data. That's what we're gonna do. Okay. I mean that's it. We don't even need to use chisel. So we'll do cast call data decode. What is the function signature of this? Let me pull up just so that I'm sure I'm working with the right. Okay, it's going to be this here. Boom. AWC20 address array, uint56 array, uint56. Oh, this will be such a sick finding if this is right. And then let's do call data A, which was this. And we see, okay, token, recipient, amount, total. Now see the same thing for their call data B. Token, recipient, amount, total. Holy shit. I think this is legit. Yeah. Because what could happen is a user could go, okay, I'm gonna check my call data against the function signature. They're gonna get this output. It's the same as this output, but it's clearly wrong. Yo, this was fucking sick, actually.
This is sick.
This was so this is actually super cool. So I made an assumption in the code here. Yeah, when I hard coded this order, I said, okay, I'm gonna save gas because it's always going to be in this order. And I was like, oh well, dynamic typing. This I was like, oh, the Solidity compiler is stupid. So like, I'm just going to be smarter than the Solidity compiler. So this is a sick finding. I think this is a high. I think this is clearly a high. Or a medium. It's a high or medium. It's a
it has a high impact, but a pretty low.
Yeah. Okay. All right. Yeah. Fair. Because you have to be.
Likelihood.
Yeah. So you have to like validate. You have to be validating your call data. So first off, you have to like do this because Solidity will never encode it like this. You have to manually create the call data, and then when you check to see if it's valid, like the ABI encoder will tell you it's valid, but the ABI encoder will never this will never be an output. So I actually fucking love this finding.
How would you go about not hard coding those?
Super easy, actually. So super easy. So instead, so what I do in here is I have what do I have? So we what is it? Number of recipients offset. So basically I just skip a step. So this order is going to be always the same. So this is always going to be the first dynamic type. This is always going to be the second dynamic type. So I need to just check. I need to check what this returns first. And so this says 0x80. I need to know, okay, that's check this. Okay. The start of the dynamic type is going to be 0x80 in the call data, and then use that to jump down here. Before I was just saying, hey, let's just ignore this one because it's always going to be here. Because I was like trying to be clever with gas, but it seems like that's not the case. Yeah, it seems like that's not the case. Like if these this could 100% say, hey, the first dynamic type actually starts way down here, and the second one starts up here, and the ABI encoder would say, yep, it's cool to do that. So
super cool.
This is a super sick finding. They might take the pot. I mean,
they will take the pot.
They will probably take the pot. Wait, well, how did I?
Scroll down.
Yeah, that's right. That's right. Add new tag. Was it call data, encoding, or dynamic type call data encoding, not fixed, medium, create and apply. Fuck yeah! What a sick finding. So like the POC is not good. Like I'm upset with
POC is not good.
I'm upset with their POC, but like sick fucking finding. Wow, this is so cool. Wow, this is so cool.
Click on expand comments.
Yeah. Incorrect statement. Hawk showed how calling with specific call data send funds to the wrong contract with coded POC. See, like at first glance, this is what I thought it was too. I was like, oh, this is like stupid. Huff does not check the argument in call data. It would be gas intensive design choice. If you're messing with call data, since you're the user of the function, you're the only one who would be affected. This is what I was originally thinking this was going to be. But I think if you manually create the call data and then you check, is this valid call data? The encoder says it's valid call data. And I think because of that, this has to be a finding. User mistake, this we handle on the front end.
No front end.
Yeah, user mistake is not a security issue.
I actually wanted to ask you something also related to this one. If the dynamics are scrambled, and if the amounts are in the recipient place and the recipient place is in the amounts place, will it go through?
Say it again. What was the question?
If the order is scrambled, and we call it with that call data with scrambled order, will it go through? Will it attempt to send and succeed?
So what would happen is if basically
and the chat, we are talking about the no check, because in the check one it will fail with the total amounts check at the end.
Maybe. I think I could come up with a POC where it fails.
We need one where it succeeds, because if we find at least one that succeeds, then funds are lost and the discussion ends right there.
Yeah, I think I could find one where it's like if you have address 0x0000012, right?
Realistically speaking,
there are a lot of vanity addresses out there, right? Like so for vanity right, like a vanity addresses or like ETH or like top ETH vanity addresses or something. Vanity ETH, Ethereum. Yeah, this is not what I want. What are like the coolest? Who has like a sick vanity address?
How many leading zeros would that have? And also, what are the chances? Let's say you're sending 10 USDC here, 10 USDC there, another 100 and another 1,000. I mean, this one would fail the duplicate check, but we have no check. So
okay, so permit 2 has this many leading zeros.
If you convert that into a uint 160,
right?
It will be a ginormous number.
It'll be a big number. Okay, well, but in any case, let's say it has this many leading zeros, right? There is a scenario where that user is now fucked. You know what I mean? Like the likelihood is infinitesimally small, right? But it's there, and like if you have a super sick vanity address, you can't get paid out, and that sucks.
That would make it a low.
Would it make it a low? Because the impact, I think the impact is high.
The funds will be lost, or at least messed around.
They'll be messed around, right? So I think impact is high, likelihood low. I think medium is correct.
Okay, let's Let's leave it as a medium.
Yeah. At first, I was like, "This is a high," but then no, you're right.
I still don't think it will go through, but
why don't you think it would go through?
you're trying to send. Okay, first of all, let's not talk about the addresses because we went straight to the addresses. If the recipient's array is now considered the amounts array, those would be extremely high numbers. Would you be able to send those numbers before hitting a balance, insufficient balance?
I mean,
You come on, you won't. Try it with 3 random addresses, and you won't find numbers sufficiently high.
So for the no check, this still needs to be fixed though, right? Like
Yes.
for the no check, this still needs to be fixed. Now it's like, okay, does this need to be fixed on the check? I see what you're saying. I'm probably going to add it just because I'm like, I bet you we can come up with a super edge case where like,
okay.
there's a small subset of like maybe 2 addresses where it doesn't work for. I think the play, it's only going to add like 6 gas, like a constant, like it's not in the loop, right? It'll literally be 6 gas. I think that's fine.
I agree.
Yeah. What is sick finding? Okay.
It is a sick finding.
Let me do a little comment here. Sick finding. We will fix this in both the no check and base huff code. Super sick. Done. Wow. Outstanding. Terrible POC though. Sorry. Screw these 2 people in particular. Okay, so now we're getting to the later section. So now we're getting like the people who kind of submitted at the end who might have done a little bit more due diligence on these. TSender airdrop ERC20 function does not check for self. Yep, it's fine. Transfer, yeah. Or what did we say this one? Like
incorrect.
Yeah, known. Isn't that funny though? We'll spend like 20 minutes on one issue and then like 2 seconds on other issues.
It was a good issue.
Yeah, it was a great issue. Unexpected protocol behavior because of some tokens have implementation only part. No, on only parts of according to the content, blah, 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 blah. Unfortunately, only what token was on all this link. No, link. That's fine. It's fine. Like I don't.
It's info, or I don't know that you won't be able to use this contract on these chains
on a chain without link. Yes. What's the recommendation? Consider reducing the list of support tokens. Maybe informational. Contracts should inherit their interfaces. Gas bad. Airdrop function allows sender to include. Yeah, we know. Correctly assumes the transfer was successful. We know, we know this. Airdropping tokens to a large number. I don't know. Like, of course. Either limit the number of recipients, whether it's small batches. Like any of those, I guess. I don't know. Differs from the Yule and Huff. Okay, line 37 of TSender reference contract. The return value of the UC is checked while it's using protocol document.
No.
States it doesn't. Yule and this is wrong.
No, it's known. Even though you check it in the reference, you don't have to check it because you mentioned it.
We'll call this out in the docs. Contract will not work. Known. It's not checking the validity of token. Huff limitation, not rejecting ether transfers. It's the no check intentional, hence the no check. Memory instead of call data results in more optimized version of the code base using memory instead of call data. So what are they? No.
I think they're providing a POC.
Well, they should have, but they didn't. I mean, this still is, you know.
It's still gas.
Yeah, gas. Gas, but I'd like to see your tests. I don't. I think what's probably happening is that the Foundry test suite is lying. How the hell do you spell lying? Oh, lying. Oh, yeah, lying to you. Memory. When you input a memory array to a function that accepts memory, it'll just leave it as it is. However, you have to convert call data to memory. But when you call this function in real life, it will always be from call data first. So we don't want to convert it from call data to memory in real life at the start of the function. Hopefully that makes sense. Maybe that didn't make any sense, but
I mean, it should make sense.
Lying. Oh my God. What?
Yes. Lying.
A common misspelling of lying. Well, oh well. Can I edit?
Yes.
Edit. Okay. Lying. Looing.
And function if you are editing it.
What's up? I spelled
when you
something
input a memory array.
Oh, okay. Thank you. Spelling. This is why I'm an engineer. Spelling was always my strong suit. If I had a recipient of list blah blah, transaction will not be accepted from mempool. Yes. It can be low vulnerability. No, because there's no like mitigation that makes sense here, right? Like what do you do? Like, oh, like have the contract do what? Like you have to reject the transaction anyways. So it doesn't make sense. Impact remains, it's a mid. Amount send should be greater than 0.
We checked this already.
We checked this. Is this TSender?
We check it in the checking function below.
Yeah. Some tokens to be stuck in the contract if the actual amount sent to the recipients is less than total amount. Some tokens to be stuck in the contract if the actual amount sent to tokens is less than the total amount. This is
in the no check.
Yeah, this is the no check. Yeah, design choice. This is in the no check contract and does not make such check. Beautiful. Okay. I think we did it.
We actually did it.
Wow, that was pretty quick.
Can you filter for not done?
Yes.
Judging progress.
Yep, not done. Oh.
Okay.
Good show. Oh, this done. Good. Ta-da.
Amazing.
Yeah. Any thoughts? Anything you think we should have done better, worse? Yeah. How do you think we did? In all honesty,
we did great. We moved super fast, and maybe I would have spent a lot more time to read some of these because I knew there are only 110, and but I mean it's great.
So you think I was too quick to invalidate people? Maybe.
Maybe.
Okay, that's good feedback for me. You're probably right, but at the same time, I knew you had already sneak peeked, so
I did. I also had 95 on my list.
You had not? Oh, like the one that we ended up validating. Yes. Yeah, that one was really cool and really tricky and really tough, and that's exactly why I want to do this audit contest, because it was like, yeah, like that would have. What would have happened is we would have deployed these contracts, and then in like 2 years, somebody would have done that, and it would have been wrong, and
most likely it would have failed.
Most likely it would have failed, and
you have to properly craft a call data to make that go through.
But the no check would not fail. The no check would probably work. Probably, it probably would have worked.
Probably.
Okay, so you're right. Like super low chance, high impact. Medium is accurate, right?
It's okay.
Yeah.
At the end of the day, it's the only valid finding in here. So whether you consider it a high or a low, he took the pot.
Right. All right. Well, yeah. Before we jump off, this was great. Had a lot of fun. That one submission in particular. Looking forward to the badass hawk that found that. That was very cool.
Also looking forward for the appeals.
Also looking forward to the appeals. I have a good feeling that me and you, just in all honesty, we're gonna reject a lot of appeals. I saw people appealing in the comments here. Let's go for appeals, I guess. But yeah, any questions from people watching before we jump off here? Any questions, thoughts, comments, feedback, anything like that? And yeah, somebody posted on here like, hey, thanks for the transparency. The reason that I like to do these is like, this is how the judging process goes, right? Like it's good to give you all some insight into how the competitive audit judges think about this. In all honesty, showed like a lot of expertise too. He said, hey, like, I knew the blast ones were going to come because I saw them, on a previous competition, right? Which was great to see, right? Like, they're aware of a lot of the low hanging fruit that's out there because they're doing a lot of judging. In all honesty, there's like a slight delay between me talking and them hearing it, so I'm kind of like stalling for questions at the moment right now. Yeah, I guess if there's no other questions, we'll jump off, but I'm going to stall for another 20 seconds once the YouTube lag catches up, and then yeah, looking forward to the appeals. Okay, good. Got a question.
Yes, Nocto. I'm reading the community judging comments when I'm judging, especially if it's a trickier submission. I'm always reading them. So thank you for leaving them.
Excellent. I would love to know the thought process for the valid issue. We kind of went through it live. I guess to summarize, basically, I had made the assumption that the dynamic types will always be in a specific order. And it's probably right that the ABI encoder will always encode it in that order. However, the ABI decoder doesn't care what the order is. So if you manually wrote out your call data and then you went to verify that your call data was right, the ABI decoder would say, yep, your call data is good, even though according to our Huff code, it's not good because we were making some assumptions about how the ABI encoder works. So that was basically the thought process. Yeah, that was basically the thought process. Anybody won? There was one valid medium, and they're probably going to take the whole pot. Cool. Well, yeah. In all honesty, any other thoughts, comments, questions from you?
We should do this more often.
Hell yeah. Well, thank you so much for joining. Thank you for being a phenomenal judge on the Codex platform. Really appreciate all the work that you put in and all the help and everything that you're doing. Thank you, everybody, for tuning in. Hopefully, you all learned a little bit more about the judging process, about how judges are thinking about this stuff, and maybe you even learned a little bit about the ABI encoder as well, and maybe some Huff, maybe a little bit about Blast. Good luck in your future competitions, and have a great rest of your day.
Have a great one, guys. See you in Sublier.